Thanks for joining me this afternoon. Today, I'm going to be speaking to you about digital transformations with Apache Spark. The format of this presentation is, firstly, my audience. This presentation is targeted towards a fairly broad-based audience. Specifically, I'm trying to target solution architects, developers, as well as PMs. I hope for other people as well, there's going to be content that adds value to their afternoon as well. So in terms of the format of the presentation, there'll be 10 minutes for Q&A at the end. In between the presentation, we'll be taking about 2 to 3 short stops for quick surveys as well. We'll be reviewing the answers to your surveys like at the end of the presentation during the Q&A session. All right, so before we jump into the actual material, first a little bit about myself. Some of you may know me, some of you may not. So a bit about myself. My name is Kevin. I'm a senior data engineer at Palo IT. I've been with the company since June of 2015. I have an engineering degree from NTU in Singapore. Prior to working in big data proper, I was doing financial systems consulting for banks in Singapore. I worked on a number of projects in that space, working with big data sets there as well. Currently, I'm working on an analytics project for a government technology agency. So that's me in a nutshell, I guess. The agenda for today is, in my opinion, fairly interesting. So we're going to kick off by talking about data systems, digital transformations, and trends in the big data space. Next up, I will be introducing one of our own client use cases where we propose Spark. And in the subsequent sections, we'll be talking about Spark a little bit under the hood. These sections are going to be a little bit more technical. And after that, I'll be introducing some alternatives to Spark, things like ELT tools and things like MPP databases. Okay, let's get started. First up, I'm going to be talking about big data systems. So databases have always been important. This has been the case for the last few decades. But I would argue that data systems are even more important today than they have been in the past. And in summary, the answer to this is expectations. Consumers have greater expectations of their digital services, and businesses themselves have greater expectations of the value that they can derive of their own functional data. Businesses and consumers are connected pretty much 24/7 by great communications links. So there's a lot of transactions and there's a lot of transactional data. And over time, consumers have come to expect great feature sets, and they've come to expect services that are on 24/7. For a more in-depth answer to this, for a more in-depth look into expectations, we can look at some of the features that consumers expect out of digital services. For example, a lot of digital services offer things like recommendations and predictions based on user historical behavior. Such kind of features are actually categorized as customer kind of customization features, and they require training models on often large data sets, and often this is done in regular intervals. So as you can imagine, there's a fair bit of expectation on a system to be able to do that in a time-effective and efficient manner. So moving on from machine learning type of features, machine learning type of analytic workloads, we also have our more traditional ETL workloads. These kind of use cases have existed for decades now. The only difference over the past 5 or 10 years is that data sizes have gone up, and businesses have greater expectations. They expect that they should be able to look at their data pretty much immediately. They expect that any reporting analysis should be run like super fast. So that's what has changed in this in the case of this use case. So in the last 2 slides, we talked about ML feature sets. We talked about ETL use cases. So those are more day-to-day things that businesses work on. However, today, most businesses often find that this is not enough. Businesses are often looking forward to the future. They're always looking for ways to innovate and to stay ahead of the curve. Terms such as digital and data transformations may have been the exception in the past, but for the past few years, they've started to slowly become the norm. And as a technology vendor, this is something that we see out there in the big data space as well. there are a number of trends, and there are a number of keywords and buzzwords that are thrown around. However, the data fabric, in our opinion, in my opinion, the data fabric and data lakes are two concepts that are key to digital and data transformations. These concepts speak about a number of things, but the most important things that they speak about are continuous access to data and data democratization. In the upcoming slides, I'm going to be speaking about how Spark empowers you or empowers organizations to achieve success on their digital transformation journey. Just as I talked about Spark in the previous sentence, I just like to highlight that the right tools and strategies are always important, and that's something that that's one of the things that we're trying to highlight. That I'm trying to highlight as a result of this presentation. So we talk a little bit about the context. We talked a bit about big data trends, and we talked. I think we've been talking for about 10 minutes. So let's take an opportunity now to take a short break. I'd like to ask you this question, and I'd like to gather responses as well. So the question is, with regards to big data trends, is there anything else that you've heard that you'd like to hear more about, or that you'd like to talk about? You can log your answer in to menti.com. You need to use the code 783486 to put in your question. I'm going to give, for this question, what we'll do is I'll give you all 30 seconds to put in your answers. You can actually put them in a little bit later as well. We'll look at your questions at the end of the presentation during the 10-minute Q&A. All right, guys, let's move on. Please feel free, if you want me to flash up this number again, please let me know, and I will do it at any time that you need. I would really love to hear what are the kind of questions you would like to talk about. All right, moving forward, why Apache Spark? So the argument that I'm trying to make during this presentation is that Spark empowers you on your digital transformation journey. It has great feature sets, great APIs that allow you to leverage data lakes and allow you to leverage ELT data processing pipelines. These, in my opinion, this kind of strong API feature set really enables you to leverage things like data lakes, really enables you to leverage things like external data, and that leverages and that enables you to, and that empowers you on a digital transformation journey by leveraging on these kind of on these two main big data concepts. By nature, Spark is a distributed system, and that allows you to scale out rather than scale up. So you're really able to work on really large data sets, and you're not limited by hardware limitations of the time. Also, we just talked a little bit about API feature sets. Spark also has great language support for lots of different types of languages. So people like data analysts who may prefer to use like a language like SQL, data scientists nowadays like to use tools like Python and PySpark. ETL coders may be a little more, concerned about performance, and they're going to be using Java and Scala. So everyone's able to use the same platform to do data transformations and to pull data from different sources. There's I mean, as long as you have the right, as long as you're giving the right people the right accesses, that's really empowering data democratization. In addition to the things that we just talked about, Spark has additional great modules that you can add on features. Things like MLlib, for example, you can add on greater statistical functions. Quite similar to pandas in Python, but these run in a distributed computing environment. So you can really run it on really big data. In this section, I'm going to be presenting a client's real life use case using Apache Spark. So this is going to be a real interest for anyone in the presentation who's got like a solutioning background or who's got a development background. These kind of these slides will speak a lot to them as well. So on this slide, I'm presenting a high-level architecture diagram that was used for one of our clients. In this diagram, the use case is, sorry, before I even go there, the client was a shipping firm. The use case of data was near real-time event data. Data could be categorized in two main categories, internal and external. The client had a lot of internal data, which is generated by sensors on the ships. So it's a lot of really critical information like pressure, temperature, engines, things like that. The client also bought external data from external sources. So it's data like weather data and sea data. In the next slide, I'm going to break down this architecture diagram a little bit. So the entry point to our system that we proposed was a resilient event store. And for that, we chose a system known as Confluent Cloud. The data lake that we chose was something that runs on Azure, and it's called ADLS, or Azure Data Lake Storage. The data lakes are really great because they're a really cost-effective and scalable solution. The client had to store up to like, I think 2 or 3 years of really raw data. And they had to do that to meet regulatory requirements. So if they store that much of data in a regular database, that may not be very scalable. So that's why a data lake comes in, and it really enables them to scale. In this slide, I'm going to talk a little bit more about the role that Spark itself has in this architecture. So the distribution of Spark that we use is Databricks. So Databricks offers a lot of services and features on top of vanilla Spark. It has great features like Delta Lake, as well as vanilla Spark features like MLlib. In addition to that, Databricks offers Databricks notebooks, which are great for data scientists to use for EDA. By EDA, I mean exploratory data analysis. So the role that Spark fulfills in this architecture is basically the compute engine. It takes all of that real-time data and crunches it and builds business and functional views. To the right of this diagram, we have Azure SQL database, and that serves as kind of the OLAP as well as the OLTP layer. So this may not be optimal, but we propose this to leverage on the client's existing licenses. So that, in a nutshell, is the high level is a breakdown of the high level architecture diagram that's in this slide. On this slide, what I'm going to do is I'm going to propose an alternative configuration. So in this alternative configuration, we're leveraging more on data lakes. So this, in my opinion, is even more scalable. So the big difference between this proposed configuration and the first one is that we're not using Azure SQL database anymore. We're storing our functional business views directly in data lake storage, so directly on the data lake. So the data lake will store raw data as well as functional data. However, it may be a bit slow to query that information from a dashboard or an app on a phone. So in that case, so for this case, I've introduced a caching layer and a REST API layer. Just keep in mind that this is a very high-level architecture diagram. You could break some of these components down even further, but I'm not going to do that in this slide. So the role that Spark fulfills here is, number one, number cruncher, like really build functional data views from raw data. And number two, it acts as a data warehouse. And for a tool and for a distribution such as Databricks, which offers additional features on top of Sparks, this works pretty well. Okay, let's take a break right now. We've been talking for another like 10 to 15 minutes. We've been talking about some fairly heavy stuff. Let's take some time out, and I'd like to hear from you. Have you ever used Spark previously, or are you considering using it on a project? For this question, what I'm going to do is I'm going to wait to get your responses. And from then, once I get your responses, I'm going to move on to the next section of the presentation. Cool. A lot of engagement. Thanks, guys. Okay. So I would say there's a fairly good representation from both sides. It's about almost a 50-50 split of people who have used it and who haven't used it. Okay, great. Okay, great. Thanks for that. That gives me an idea of that gives me an idea of the kind of how much of how many people have used the platform already and who hasn't, and how many haven't. All right, so I'm going to move on to the next section. So this section is going to be a little more technical. I've got some slides with some code, but I'm mostly going to be talking about, again, high-level stuff. The intention is that if you do start using Spark, what I would like you to get out of this section of the presentation is things to look out for, things like joint performance. Joint performance is something that you're going to be spending time on. You're going to be putting some focus on. All right, so before I go into that, I'm going to start by introducing data structures. I'm not going to go into great depth on data structures, but I am going to introduce the lowest level and the high level APIs that you need to know about. The core data structure in Spark is the RDD. However, and there are even APIs to manipulate the RDD. However, those APIs are currently deprecated. So what's recommended is to work with the higher level APIs, which are Dataframe, Dataset, and SQL APIs. So on the diagram on the right, what you have at the right at the bottom are different storage types. You've got JSON, you've got different types of databases, you've got different storage formats. The layer on top of that is the core data extraction, which is RDDs. And the layers above that are the higher level APIs, which are the Dataframe, SQL, and Dataset APIs. Okay, cool. So I've just tried to give you an idea of how these things layer up. Let's jump right into something else right now. On this slide, I'm going to try and help you visualize a data frame. So it basically does look like a table with rows and columns. And on this, I have a code snippet here as well. I'm trying to give you an idea of how easy it is to use the different functions that are available. So in this code snippet, what I'm doing is I'm taking a large data set. I'm grouping by a number of fields. I'm doing an aggregation on a field called requests. Then I'm renaming that field from request with a small r to request with a big R. And then I am ordering by date of the week. So the API names kind of make sense. The function names make a lot of sense. And it's fairly easy to write code like this. So what ends up happening is that you're able to focus more on the high-level business logic, and yeah, you're able to deliver much faster. The screenshot that I have here is taken from a Databricks notebook. So it's this is another really easy and convenient tool to use. Yeah, so I'm going to talk a little bit about actions and transformations. So the functions that are highlighted in bold, group by, sum, with column renamed, and order by, are classified as Spark actions. Whereas the display that I have here, which is underlined, that's classified as an action. I'm sorry, group by, sum, and order by are classified as transformations. Transformations are evaluated lazily. So this means that you can really chain a lot of stuff. Once you want to view that data, you can use something like display, and Spark's going to look at everything and it's going to optimize it for you. Okay, cool. This might be, okay. So here what I have two tables. One is blue, one is green. On the blue table, I've got registration details, right? Which is partitioned by the make of the car, by the model of car. The green table is more about pricing of different types of cars and different models. And this is, again, partitioned by make of car. So when you use a system like Spark, I'm sorry, let me rephrase that in a different way. If you're not using a system like Spark, if you're using like Pandas, for example, and if you try to do any sort of operations on this data, all of this data is going to stay on your computer. So it's kind of limited by the configuration of your computer. However, if you're using a system like Spark, which is a distributed computing system, what it's going to do under the hood is when you start doing an operate, when you start trying, for example, if you're trying to join these two tables, what it will do is it will send all rows which are of make Spark to node 1, or for both the blue and the green tables. So when both the blue forwards and the green forwards are in the same node, that's when Spark's able to like summarize or sum or anything like that. So this sending of data across nodes, I mean between nodes on in a cluster is called shuffle. I'm going to take a pause now. I'm going to ask you a question. Did any of this make sense? Do you have any questions that you'd like to ask me?
Kevin, this is Sukalpo.
Hey, Sukalpo.
So when Spark does the shuffling, right?
Yeah.
Is it based on the partitions that you create?
Yeah.
Okay, so when you say that all forwards will be transferred to one node, it means that I have to create a partition on the make column, is it?
Yeah. Yeah, you do. But you don't need to do it. You don't need to do it manually. Like you can do it manually. But for example, if you look at this previous code snippet, if you choose to do a group by, it's going to do that under the hood for you.
Oh, okay. So
yeah,
group bys are creating partitions for you.
Yeah.
Okay.
Yeah. So this is so these function calls belong to the higher level APIs. If you're using like a lower level API, which are deprecated, like the RDD ones, like I spoke about earlier, for those, if I remember rightly, those you really need to specify, okay, I want a partition on this field, right? And you really need to specify that. Whereas if you're using the high level functions, you don't need to do that.
Got it.
This is more to give you an idea of like what it's doing under the hood, because I want to talk about shuffle and I want to talk about why it's not, I mean, why you try to minimize shuffle.
Okay.
All right. Does anyone else have any questions? Okay, great. If you do have any questions, let's talk about it in the last 10-minute Q&A session. All right. So in this section, I'm going to be talking more about join performance. Shuffle or network shuffle is a key consideration to join performance. Shuffle is slow because, like in the previous slide, when you saw that you're moving all the forwards to one specific node in a cluster, when you're moving that kind of data across a network, sending stuff across a network is very, very slow compared to doing anything in memory or doing anything on disk. So a big consideration to join performance is about minimizing shuffle. Okay, so the most basic type of join in Spark is called a ShuffleHasJoin. So the way the ShuffleHasJoin works is if you have two tables, what it's going to do is Spark's going to look at each row in the table. If it's looking at the car example that we looked at earlier, it's going to look at, for example, the make column, and it's going to do a hash on, on the make column. So for example, it's going to take Ford and it's going to make a hash. It's going to take Honda and it's going to make a hash. Then it's going to, and when it hashes it, it's going to create something called an output key. At that stage, what it's going to do is going to shuffle rows across different nodes in the network based on that key. So for example, all the Fords go to one server, all the Hondas go to one server, all the Toyotas go to another server. The idea of a big data system doing this is basically to divide and conquer, because I mean, scaling work out really, that's what big data systems do. That's how they achieve concurrency. And that's how they speed up job performance. They basically divide jobs up. They divide data into smaller pieces and work on all those pieces in parallel. So with Spark, you have these APIs where you can just write, group by sum, but under the hood, it's going to do all this stuff for you. So coming back to the ShuffleHasJoin, the ShuffleHasJoin is great. I mean, it's the most basic join type, but there are two main things that you need to keep in mind when you're doing a join with this join type. Number one is ShuffleHasJoin works best when the data set is kind of evenly distributed on the join column. So for example, if you have 20 Fords, 20 Hondas, 30 Toyotas, and you want to do something on these, there's 20 Hondas, 20 Fords, 20, 30 Toyotas, it's going to be pretty fast because you have three groups that are about the same size, so they're all going to take about the same time. However, if you have another distribution where you have like 10 Fords, 200 Hondas, and 5 Toyotas, the Toyotas and the Fords are going to finish really fast, but the one in the middle, the Honda, is going to take forever because there's 200 Hondas, and it's just going to take a long time. So yeah, so if this partitioning is uneven, you can't really parallelize that much, and yeah, so you're not going to get your job is still going to be slow, and it's not something that you can really beat. So there are ways to get around this. We can talk about it in the Q&A session, but for now, I'd like to move on to another join type. The broadcast join is also a fairly common join type. So this is an example is you have a really big data set and you're joining on a really small data set. So your small data set could be a lookup data set, where you're looking and suppose like dialing code versus number, right? So 65 is Singapore, 90 is, oh, I forgot. Yeah, 91 is India, for example, stuff like that. So that's going to be fairly small. It's going to be like 200, 300 rows. So when you're doing, when you're working with this kind of join, for example, what Spark will do is it'll take that small data and it'll copy it to all the different nodes in the cluster, and everything will join locally on that node. So this is a lot faster than if it was to use the ShuffleHasJoin, for example, because you have one data set that's really, really large and the other one that's really small. So you're not going to get a lot of parallelism in this case. So the broadcast join in this specific use case is an optimization. If you're using specific data formats such as Spark will be able to know that there's a big difference in size, and he'll be able to do it automatically for you. However, if you're using some other like obscure formats, this may not happen automatically for you, but you can actually specify that in code using the broadcast hint. It's part of the Dataframe API. Okay, cool. Oh yes, I think I mentioned that here. Broadcast joins also work really well when the lookup table can fit completely in memory, because then a lot of those operations can be done in memory. So in the next upcoming slides, I've just put in a few notes about some of the different modules. These 3 slides are more for your reference. You can take a look at any time. I'm not really going to go through them right now, because it's kind of information that you can get from the website as well. So I'm not going to go in detail about these. So we've reached the end of this technical section of the presentation. What I'd like to do is I'd like, again, to take another break, just to get a fresh mind to move forward. There's about just one more section left where I introduce different alternatives. But before that, I'd like to hear your responses to this question. So with regards to joins or data structures, what else would you like to talk about? Please feel free to visit menti.com and use the code mentioned here. I'd like to hear more about what else you'd like to talk about in this technical space, and we can answer it in the Q&A session that's after this. All right, cool. I'm going to move on to the next section, and in this section, I'm going to be talking a little bit about alternatives to Spark. You have systems that are known as MPP databases that are massively parallel processing databases. Databases such as BigQuery, Redshift, Snowflake, and Teradata. So these databases work kind of in the same way. They partition data on a specific column. They distribute them, and they take a divide and conquer approach to working with big data. These are in my opinion alternatives. especially since some of these databases can actually read data directly from a data lake. So that's kind of a feature. That's kind of the same feature that Spark offers as well. So if you're considering a tool for your project, MPP databases are also something you should look at, especially if you don't have a real-time component to your requirement. Some of these databases have full read and acid writes on external storage data. With Redshift, for example, Redshift has Redshift and I think Bigtable as well. They don't have a separation of storage and compute. So if you wanna scale up your cluster, you have to scale up both storage and compute. So it ends up being quite expensive. So for example, if you need like 10 GB extra storage, but you don't need the extra compute, you're still paying for both anyway. So separation of storage and compute is definitely something that that really helps with pricing. So with Spark, you can also access into external data, such as data files in a bucket, but you may be in charge of partitioning them properly. However, with like a database such as like with BigQuery, I think you can specify like different table settings, and the database will manage this optimally for you. Spark has a module called Delta Lake that's really powerful, and that allows you to use Spark as a data warehouse. So you can really do acid writes and reads on external storage such as S3. Okay, cool. In this section, I'd like also to talk about tools that are broadly classified as ELT tools. So the AWS Athena is an example of an ELT tool. So what this does is Athena directly connects to external data set that you have, in S3 or in HDFS, and you can directly query that data, and you can actually perform computations on that data. It's not a good use case for a production workload, but if you're doing like analysis or you're doing explorations on a data set, it's a great tool to use. It's serverless, and you typically only pay per KB of data query. So there's no setup required as well. All right, that brings me to the end of my presentation. What I'm going to do now is I am going to look at some of your responses, and I am going to try to answer some of them. Okay, cool. Data systems and Spark. Okay, wow. Okay, cool. NLP, data governance, Shazamming data factory workload. Okay, how to do smart data with big data. Nothing specific at the moment. Okay, cool. With regards to NLP, maybe let's talk about NLP. Could you specify a little bit more about that? Whoever asked that question.
It was me, actually. I'm just curious to, hear your thoughts about where NLP could be applied in the future. And do you think NLP is also something that could leverage off of Spark's strengths?
Yeah. Yeah. So for an example, I think I'm going to take a simple example of like doing some sort of clustering on, textual feedback data that people have input on that is gathered using an analytics platform. As an example, a simple so like I mentioned, a simple NLP application would be clustering on that on that data. So if you're using Spark, for example, you could use MLlib libraries like because there are regression and classification functions that you can use with MLlib, and you could use that to categorize different types of words and different types of sentiment.
Cool, thank you.
Sure. How do you validate the data well? That's a good question. Who asked that question? I mean, do you have anything in specific that you'd like to talk about?
I asked that question. No, I don't have anything specific, just a broader question.
Okay, that's a very good question. To be honest, if you're working with data, you spend a lot of your time just validating data. So in my experience, validation occurs both right at the start when you're trying to clean data. It also occurs right at the end, because once you get that raw data and you run your models and you build business data, sometimes there's things you missed when you're cleaning raw data and they show up in your models. Things like duplicates, things like unclean data that you didn't think about. Duplication is something that's happened to me as well quite a lot. So in my opinion, validation occurs right through the pipeline, right from when you're looking at raw data, even up till when you're looking at modeled or business level views. Yeah, it's a very big question, and it requires you really need to keep looking at data. You really need to map it to the use case as well. You need to you need to map. For example, if you're looking at a functional view, you need to be able to look at a piece of the report and say, does this make sense? And yeah, so it's a really big and it's a really good question. Okay, data factory workflow to import and transform disparate, siloed, and legacy data into a data lake. Okay, cool. I think this may be, okay, I'm not gonna guess. Okay, cool. Okay, cool. So I'm going to attempt to answer this question. So this is, I guess, you're trying to use Data Factory to take data from different sources and move them into a data lake. Okay.
Yes, that's correct.
Okay. Oh, thanks, Justin. Okay, cool. Yeah, you could use data. I personally have not used Data Factory, but I've read a lot about it. I think, yes, it does work that way. You could also use Spark to do the same thing as well. But you would need to write your own code to do that. As with Data Factory, you may have built-in transformations that you can add on. Yeah, I'm sorry, I have not used Data Factory myself. There's a lot of big data tools, but the sense that I get is if you're using Spark to do this, you would have to write some of that code yourself.
Yeah, that's what I assume. Okay, that's cool.
Cool. Okay, so this might be Sukalpo, Shazamming data.
How did you guess that?
I don't know, man. Okay, man. Okay. Give me some more information.
Yeah. So yeah. It's nothing. I mean, I was listening to a tech talk by a technologist, and he was saying that one of the big data trends that's coming up in 2020 is Shazamming of data, which basically we know Shazam, right? The app,
yeah.
mobile app. So now the trend is to Shazam any other kind of feature. So you see a picture, you Shazam it, and you find out what that is basically. So how do do you think that Spark comes into picture in this kind of scenarios?
Yeah, this is an image classification. That's an image classification problem. So yeah, you can use Spark for that kind of work. Yeah, you definitely can use it. I'm not an ML expert at the moment, but yeah, I can't tell you what ML algorithms you can use right now, but yeah, Spark is definitely used for this kind of use case.
Cool, thanks.
Sure. Okay. Let's move on now. Let's look at the last section. Okay, cool. Okay, what kinds of data formats are most commonly used? JSON, Parquet, ORC. Parquet is a columnar data store. So if you're looking at data warehousing, this of course depends on your use case and on your actual data. But if you're looking at data warehousing, Parquet and ORC are really good data formats to use. JSON and CSV are also commonly used. With Parquet, you have compression as well. You can just specify it and the engine will do it for you. So you can really save on storage space. can we have a demo covering the overall presentation? Sure, we could. I could work on something. Yeah, I could work on something for you. Like I mentioned at the start of the presentation, this presentation was mostly meant for a broad-based audience. But for a more technical-minded audience, I could do a demo. I would do it in a notebook, so it's a little more visual. But I could definitely do that for you. What are the join types available, and what's the best way to use those joins? So we covered two types of joins. We covered ShuffleHasJoin, ShuffleHasJoin, and we covered the broadcast join. So these are the two main joins that you need to know about. If you're ever doing a join on two data frames, there's a function called .explain, and when you do that, you can actually see the explain plan. If you're doing a demo at a future point in time, that's something that I will definitely cover. There are other join types as well. There's a Cartesian join. I've not really used it in a production environment, but I know that there are use cases for it. Yeah, the two, I would still stick with the two main ones because they cover most of the use cases. In terms of the best way to use those joins, I think that can be covered in a demo. It's a fairly big topic. The two main things that you need to keep a note of is that data is partitioned evenly across both the tables, and that there's not a big difference in size between both of them. That's the two main considerations I would say at this point in time. But if you're doing a demo, that's something I would explore in more detail. Joins are mostly dependent on data size across the table. Is there any tool looking into data ML that can suggest best join strategy? So when you're using, so for example, if you're using Spark, or even if you're using any MPP database, both those tools are going to look at the data both those tools are going to look at the characteristics of the data and recommend the best join strategy. So for example, if you just do a join on two data sets and if you look at the explain plan, you will see what Spark is doing, and it's going to do that based on the characteristics of the data. It's going to look at the number of partitions. It's going to look at the sizes. It's going to look at stuff like that. May I know who asked this question?
It was me, Rupesh.
Hey, Rupesh. Did that answer your question a little bit?
Yes, yeah.
Okay. So you can actually configure it. Like you can actually say, like you can actually specify what type of join you want to use. But even if you don't, you know, all those tools are going to look at the characteristics of your data, and it's going to recommend the best way to do it, and then it's going to do it in that way.
Yeah, thank you. Thanks.
All right, guys, we've been talking for quite a long time. Thank you so much for your time. I'm going to end the call right now. Thank you so much, and I hope you got value out of this. Take care and stay safe, I guess.
Thanks a lot, Kevin.
Thank you.
Thanks. Bye.
Bye.
Thank you. Bye-bye.
Thank you.
Thank you very much. That was brilliant. Thank you.
Thank you.